Welcome! Today, we're diving into something that could completely reshape our world. We're going to explore how carbon removal technology isn't just about cleaning up the climate, but about building an entirely new economy from the ground up.
All right, let's jump right in. But here's the thing, we're not going to start with the problem. No, we're starting with the end game, the most exciting, futuristic vision.
I mean, that sounds like something straight out of science fiction, doesn't it? But what if? What if that one question could totally flip the script on our industrial future? It's a pretty wild idea, I know, but stick with me, because we're going to break down exactly how it might just work. So, to really get our heads around this, we have to make a huge mental shift. We need to stop thinking of carbon dioxide as just, pollution or waste, and start seeing it for what it really could be: the ultimate resource, the raw material for a whole new wave of technology. So, this is not just about cleaning up a mess. It's not just subtraction, pulling carbon out of the air. It's about addition. It's about building the very foundation for a brand new zero fossil fuel economy that gets us to 100% clean energy way, way faster. Okay, so how does this magic actually happen? Well, at the heart of it are these incredible materials called metal organic frameworks, or MOFs for short. The best way to think about them is like molecular sponges, but these are super sponges. Get this, a single gram of this stuff can have the same surface area as a football field. It's insane. And they're engineered to do one thing with incredible precision: snatch CO2 molecules right out of the air. And what's really cool here is how flexible this tech is. You can use these MOFs in these huge, sprawling facilities for what's called direct air capture, basically giant vacuums for the sky. Or you can be more surgical about it and put them right at the source, like at waste-to-energy or biomass plants, capturing the CO2 before it even gets out. Okay, so we've got the tech. Now let's see how it all fits together to solve one of the biggest headaches for renewable energy. We're talking about something called the carbon flywheel effect. Right, we all know this problem. The sun isn't always shining. The wind isn't always blowing. So what do you do with all that amazing, clean power you generate on a perfect day? How do you save it for a rainy one? Or, just for nighttime?
And this is where that flywheel idea comes in. It's brilliant. Instead of having to shut down wind turbines or solar panels when they're making too much power, which, yes, that actually happens, you take all that extra, surplus energy and you send it to a carbon removal plant. That plant uses the power to capture CO2, and then that CO2 gets stored, or even better, turned into valuable products. It basically becomes a way to store that energy for later. So the key takeaway here is pretty simple: no wasted energy. Not a single kilowatt. Every bit of that extra clean power is put to good use. You're stabilizing the grid, making it reliable, and you're creating valuable stuff at the same time. This is a total game changer for how we manage our power. But this flywheel, it does more than just balance the power grid. It actually becomes the engine for a whole new kind of economy, an economy built on carbon. So that captured CO2, it's not waste, remember? It's now the raw material for all sorts of amazing energy storage tech. You can literally compress it to store energy. You can use it to create synthetic graphite to make better, longer-lasting batteries for, everything. You can even make these simple thermal batteries, kind of like high-tech bricks, that can store heat for factories. And just look at this value chain. It's incredible. You can take something simple like biomass, run it through a process called gasification, which is basically just a fancy way of turning it into a gas, and from that, create these mind-blowing materials like fractal graphene. I mean, we're talking about turning plants into materials for the next generation of electronics. It's like modern-day alchemy. So what we're really looking at here is a complete flip in how we think about our economy. We're moving away from the old model: dig it up, burn it, throw it away. Linear, extractive, wasteful. And we're moving towards something that's circular, regenerative, a system where the waste from one process becomes the fuel for the next one. It's just smart.
But believe it or not, the impact of all this goes way beyond just factories and power grids. This is about reshaping our planet and even helping us reach for the stars. So the land around these new energy parks isn't just empty space. It becomes a vital part of the solution. Think about it. You can have solar panels and crops growing together. That's called agrovoltaics. You can actively improve the soil so it stores even more carbon. You can even use special plants to clean up old pollution, literally pulling heavy metals out of the ground that can then be harvested and recycled. It's amazing.
And if you thought that was cool, get ready for this. Using a well-known chemical process, you can take that same CO2 we pulled from the air, combine it with hydrogen, and create ultra-pure rocket fuel. We're talking carbon-neutral fuel for spaceships, made from thin air. This could completely replace the fossil fuels the space industry relies on right now.
And this is where we come full circle. Back to that crazy question at the beginning. If you're making your rocket fuel, and maybe even parts of the rocket itself, out of carbon you pulled from the atmosphere, then every launch could actually be carbon negative. Think about that for a second. Sending rockets to space could literally help clean our air.
So what this is all about, really, is turning our biggest problem, a global liability, into our greatest asset. This isn't just about stopping a bad thing from happening. It's about building the foundation for a truly abundant future here on Earth and out there in space. So the question we have to ask ourselves isn't just, how do we survive? It's, how do we want to thrive?